So my watch says that I've got 3 minutes left. The watch in the back says that I can start now, so I'm going to start now. So I'm going to trust that for starting and mine for ending. That's going to give me 3 minutes extra. Because it's a slightly longer session normally, so I'm trying to get as much as I can into the 50 minutes. And we should be good to go. And as you see, I have renamed my session a little bit. It's now called Worked on my machine. Because as of about an hour ago, I realized that all of my demos failed on my machine. Because of a change in ASP.NET Core, none of my demos work. I believe I have fixed them, but who knows? Let's see. So demos might be a little bit sketchy today, but hopefully they will just fly and there will be no problems. I'm blaming Microsoft. So, my name is Klug. I work for a company called 1337, where I work as a software developer / architect / public speaker. I go around to companies doing teaching, I do software stuff, and I go to conferences talking about the stuff that I want to share and teach other people. Because I do believe that if somebody spends a ton of time learning something, sharing that with someone else kind of makes sense, so that you don't have to go through all of the stuff that I needed to do to get to the point where I am in that thing, and other people can show me what they've learned because it just makes sense. And Docker seems to be one of those things that for some reason appeal to me. I'm a developer. I am not an ops person at all. I dislike just managing systems. But for some reason, Docker is cool. And why is that cool? Because we all deploy software, right? Is there anyone in the room that's not deploying software? Hands up. Not a single one. So we're all deploying software, right? We've been doing this for a while. I've been deploying software to production for the last 20 years-ish. And they're all kind of complicated because every single thing we deploy is a little bit different. There's always the challenge of, oh, it's a new thing. And how many of you have been in the, oh, we're going to have a deployment on Wednesday, so you better not make any plans for Wednesday night because you might stay late? It's a pretty common scenario. Let's not have that, right? So we all deploy to different environments. That's one of the biggest problems because we deploy our code as we check in. It goes to a CI pipeline. And then once it goes through there and we're okay with that, it goes to a UAT environment. And then once UAT has accepted it, it goes into production, right? And all of these environments are different. Any client that says that, oh, our environments are identical in each place is probably lying. Because we do CI/CD potentially to a build server somewhere that we are hosting or some other system. UAT is a micro version or a smaller version of the production environment, and the production environment might be cloud, and it might be completely different. Or we might run it in our own data center, but I promise you that UAT is probably not going to be identical to your production. And I have heard clients say, the environments are pretty much identical. Have you any idea what pretty much identical means? Not the same thing at all. And that's kind of where we come into Docker and we go, you take a step back, and I know this is like the corniest analogy ever, but you start looking at software and you go, are we the only people sending oddly shaped packages to different destinations? And when I go to this, people are going to laugh, right? Yeah, you're completely stupid. Because there's no correlation between sending oddly shaped physical packages to different destinations and a correlation between that and sending oddly shaped binary packages to different destinations, right? Yes, there is. It's literally kind of the same thing, except for it not being physical, it's being digital. But we are doing it, and they have done it before. And these guys, they came up with this. I love containers. I don't really know. It's like I love physical containers, not just computer containers. I like those. I have no idea why. They're just pretty awesome. I have a background in sail racing and professional sail racing. So shipping things in containers has been a big part of what I've been involved in for a few years. And containers are cool because they're so simple. Every single container in the world, basically, more or less, conforms to a very simple formula. Basically, that's the table down there that says these are the different versions of containers that are available. They are all within 3 different lengths. I think there are 3. It's like 20 and 40 foot are the normal ones, the ones that everybody uses. There are 2 different heights on them. And really, the shippers only care about one single thing. That is where these corners are located. Because those corners contain the locking mechanism to manage a container. So anything you do between the 8 corners of that container is pretty much, we don't care. Do whatever you want. As long as those corners are placed exactly where the spec says, we are happy. And I can take this container and I can ship it on a truck. I can take that container, move it from the truck to a boat. I can take it off the boat using a forklift, and they all know exactly how to lift and how to move things because the corners are in the same place on every single container. It's that simple. And yes, you can build houses on it, but that's really has nothing to do with this. They're just very versatile. That's kind of what I want to show you. And that's where Docker comes in. And that is why Docker even has containers on top of the whale. It's all about that idea of giving us fixed corners to what we're building, giving us a fixed format that basically it gives us a box, a container to shove stuff into, gives us fixed points to connect it to a running system. The running system knows that there will be fixed points for me to attach to. Whatever you're doing inside the container, not my problem. So what is Docker? Docker is kind of like a VM that uses the host operating system. Ish. And then not really at all, but kind of. So if we look at the difference between VMs and containers, and I like having that definition or that view of it, because most of us, how many of you have played with VMs at some point? How many of you have played with containers at some point? Why are you in here? Okay, so it's kind of good. We all have VMs, so that's kind of the baseline that we go with. When we're packaging stuff up, VMs was this way that you could do it before. Containers are a little bit different. So in a VM, you've got infrastructure, so you've got hardware. That could be your local machine. It could be a cluster of machines, whatever. It's hardware. It's physical stuff. On top of that, you've got a host operating system. In our case, I guess most of us are running Windows, but it can be Linux. It can be OS X, if you for some reason want to run that. On top of that, you put a hypervisor, something that basically virtualizes all of the hardware. So when we put a virtual machine on this, and inside the virtual machine we put an operating system, that operating system believes it's talking to physical hardware while it's actually talking to the hypervisor, which is basically emulating hardware for it to use, right? So on top of our operating system, we then put our binaries and libraries that we need inside of our VM, and we put the app on top of that. And we can then put multiple versions of, or multiple VMs on the same physical machine, and that is fine, everything just works. But it's a pretty hefty load of having the OS. So if you're looking at VMs, they tend to go into the region of 15, 20 gigs for a Windows VM. Kind of heavy. So what containers does is infrastructure. We kind of need that. We can't run it without hardware. Even if they've got this thing called serverless now, it doesn't mean that there are no servers. It just means that it's somebody else's server and you don't care. On top of that, host operating system. Without an operating system, we can't do anything. On top of that, we don't have a hypervisor. We have a Docker engine. So you install Docker on the host machine. You put the Docker engine there, and then on top of the Docker engine, you put your container, and inside your container, you put your bins and your libs, and you put your app. There is no OS in here. So what happens is that the container, and then obviously you can put multiple containers onto the same machine. But the cool thing is that there's no OS in there. So there's no OS that needs to be patched. There's nothing in there that has to do with the operating system. What happens is that the container uses this operating system. So it basically goes down and uses the host operating system. But it uses it in a namespace way so that if you install something on the host operating system, it will not be installed in containers. So anything you install on it will not be available in your container. So if you're running Windows containers, for example, even if you on your host start installing IIS and stuff like that, inside your container, there's nothing. It's a raw nothing image or version of your operating system, and then your container contains everything that it needs. And containers are namespaced separately as well, so something you install in one container can never affect something in another container. But an image like this can come down, instead of gigs, we're talking Alpine Linux distro is, I think, 6 megs or something. And my mic just died. Oh, I was just too loud? Okay, sorry. I know, I've heard that before. So they become really, really small. So we can start deploying things in megs and not gigs. And when you're trying to move fast, you can't start moving around 10 or 15 gigs of data, because you will have data transfer interruptions and you have to restart and all that. If your containers can get smaller, you can deploy faster. And if we look at the anatomy of a container, basically what is a container? You got the host OS, which is the OS of the host machine. Then you put an image on top of that, which in this case would be Ubuntu. So every single container uses images to build up itself. I'll come back to that. But it basically has a base image. In this case, I've chosen Ubuntu. Most of our containers will start with some form of operating system on top of the host as well in the Linux world. So even if the host is running Debian, with Linux I can actually switch the kernel because there's a microkernel in there, so I can run Ubuntu inside of my container while running Debian outside of it, for example, or the other way around. But every base image has something except the base image Scratch. So Scratch is an empty base image, and if you're really good at Linux stuff, you can use that to build your own image from scratch. That's the name Scratch. If you're not a Linux guru, then you take one of these. On top of that, when you start a container based on this image, Ubuntu, your container is put on top of that with its own writable layer. So an image is always read-only. And then your container contains its own little writable layer. So when you write something to disk inside of your container, it's written to disk in your container, and when your container dies, your disk stuff just disappears. So images are kind of, if you were looking at the software developer world, the image would be your class, and your container is your instance. So the class defines what you have access to and what it's supposed to look like and all of that, and the container is the running instance of the blueprint that you have from your image. And then I can go ahead and I can add multiple containers on top of the same image, but I only need to download the image once. So on my machine I can run 400,000 Ubuntu containers, but there's only going to be one Ubuntu image because they're all sharing that same layer, so I only need to download that once. And if we set everything up properly when we build our images, we can reuse different layers inside of the image across a bunch of different other images, so we can basically mix and match and do really cool stuff and save space on our hard drive. Because that's another problem. If you're going to run 400,000 VMs on your machine, you're going to have the biggest hard drive I have ever seen. So this is kind of cool. And we can also then take a base image and add another image on top of it. So I start out with the Ubuntu one, and then I add .NET Core to it. And then on top of that, I add some other stuff that I need, some other packages that I need to install for my application to run. And then on top of that, I start my container. That means that I'm going to share this image, but there's going to be other images on top of this that I need for my container to use. And then I can have other containers that only use the .NET Core version of that container and so, or that image and so on. And on Linux, which is kind of cool, you can, as I said, switch operating systems. So if you want to do Ubuntu, that's fine. If you want to do Debian, that's fine. If you want to do Alpine, that's fine. Basically, anything you want to put into an Linux distro, you can put on there and basically switch whatever OS you're using. How many of you in here are Linux people? So you know more than I do, because I don't use Linux at all, more than in Docker. And then we can do Linux-specific things, add Emacs, and we can add a container on top of that. So images in itself are kind of interesting because those are the building blocks of our containers. So they all start with a parent image, Scratch being the grandfather image of every single image ever. It's empty, and then you add stuff on top of it. And then your image has a reference to its parent. And inside of my image, I can basically say, oh, I want to copy these files into the image, and then I want to set this environment variable, and then I want to copy these files in there, and then I want to say that when this image starts up as a container, I want to run this exe file. Every one of these things, like copying a couple of files, setting an environment variable, copying another couple of files, actually creates a unique layer. So it's not just one image. An image consists of layer upon layer upon layer upon layer of data. And then we run the container on top of that. And if we look at this, if I were to create a completely different image based on the same parent image, but I did the same copying of files and the same environment variable configuration, they would actually reuse the same layer. So each layer has a hash containing basically a hash of the information in that specific layer of data, so that if it finds a layer that has the same hash on your machine, it will actually reuse that layer instead of creating a new one to save disk space. So every layer is a little layer of data on top of a previous layer, and then another layer, and another layer, and another layer, until you reach the stack of stuff that you need on the drive inside of your container, and then you create your container on top of that. And if all these images are kind of exposed to us somehow, like NuGet. So we take these images, we build them on our machines or our CD servers, and then we push them to some form of registry. The standard way of then getting them from the registry onto your machine is you go into your console and you write docker pull and then the name of the image that you want. So docker pull is the command, and /my_image is the name of the registry or the image that I want to pull down, or sorry, the repo that I want to pull down. It actually means this. Docker pull automatically adds hub.docker.com unless you have specifically added another registry. So it defaults to Docker's own repo, but you can go and create your own repos in Azure or Amazon or your own custom implementation of it. And when you do, you're going to have to change the pull to actually use the whole name of it and not just the hub.docker.com that it automatically adds there. And if we look at the actual address, what we got here is actually it does that. Because if I don't specifically add that colon something at the end, it just adds latest to it. And I'll explain that in just a second. But if we look at the URL, what we've got is the name of the registry, basically what registry is hosting my images. In this case, it's hub.docker.com, which is the default one. This is the name of the repository, basically the name of my image. And it can look a little bit different depending on if you're on hub.docker.com or somewhere else. And then the last thing here is a tag. So every image has a tag that you can add. So whenever you build an image, the latest version of that image, that latest one with the same name, /my_image, gets the tag latest. Then you can tag them with other things. So you can take an image and say, I want to tag this as v1.0. Or I want to tag this as dev build version whatever, blah, blah, blah. So you can add whatever tag you want to it so that you can define different things and then deploy the dev version to this environment. And then once you're okay with that, you can retag it and deploy it over there and so on. So you can tag images and keep track of them. And that's used a whole lot. If you look at the stuff that I'm going to be doing, Microsoft uses the same image for everything that has to do with .NET Core. So they've got Microsoft / I think it's .NET only now, colon, and then what version of .NET you want. So there's a version, so you can go 2.0 or 2.2 -SDK. That's a .NET image that is version 2.2 and includes the SDK. And then there's like a 2.2 only, which doesn't have the SDK. And then there's an ASP.NET Core runtime. So it's 2.2 -ASP.NET Core runtime that is basically the same image, base image, but it includes no SDK and it's only there for running and so on. So you don't need to have unique images for everything, you must tag them. So if they're in the same realm of things, you add different tags and you can figure out what to use based on the tag. So, getting started. How do we get started with something that is Linux based in a Windows world? Because I'm running Windows, I've been running Windows all my life except for 2 very weird, curious Mac OS years in my life. And I thought this is going to be hard. This is going to be a tricky thing, and it's not at all. You browse to docker.com, and you go to their Docker desktop area, and they have a download page. And the reason I renamed my thing here as well to worked on my machine was that when I opened my machine an hour and a half ago, it actually said, when I wrote Docker in the command line, it said, I don't know what Docker is. It had uninstalled Docker on my machine for some reason on top of that. So I've reinstalled it this morning, so it works. I know this. You just click download for Windows, or Mac if you're one of those. And it installs a few things for you. So it installs a VM for you that runs Linux. It's the mobile Linux VM up there. Minikube you can ignore, that's a Kubernetes thing. That's my machine. And then it installs a little systray thingy that gives you access to Docker information and settings and everything for your Linux VM. And it installs Docker in your terminal so you can access it. So it's all done. You don't have to do anything else. It does a ton of magic networking stuff for you. I'm not even going to get into it. It's complicated, but it just works on your machine. But there's lots of thought behind getting this to work. So what does it mean running a container on your machine? Let's see if my demos work. This is a console, even though it's weirdly colored due to the light in here. So if we do Docker, let's do Docker images. You can see that I have a few images on my machine already. And then we can do Docker run -IT runs it interactively. So what it does, it connects the standard output to my console and the standard input from my console. So basically, I'm going to end up having a sudo TTY connection to it, so I'm inside the container basically. And then I'm going to run Ubuntu. And for some reason my machine is ridiculously slow today, but that's me inside of Ubuntu. So if we run ls, we can see I'm inside of an Ubuntu image right now. I'm running Ubuntu on my Windows machine. I can do really cool things. Previously you could run ipconfig in here, but for some reason that's not available anymore. I don't know why. But you can do Linuxy things in here if you're a Linux person. I'm not. So let's head out of this. And once I hop out of it, if I go docker, so docker is the main command for everything. PS is basically, please list all of the images, all of the containers running on my machine right now. And it says there are no containers running on my machine at all. That's because it only shows me running containers. And as soon as a command, in this case, I go exit and I terminate the bash in there, it basically kills the container. So as long as there is a running process inside of the container, it will keep the container alive. As soon as that process dies, the container dies. So we can do docker ps, but we can add -a, and we can see here that it's fairly weirdly formatted. I'm sorry about that, but it basically has, I have 2 containers on my machine. None of them are running. I've got the one that I just set up that runs Ubuntu. It has a container ID, which is the name of the container, or the ID of the container. It tells me that I was running bash inside of it. It started about a minute ago, and I ended it about 36 seconds ago. And it also gets a human-readable name, in this case, Admiring Mendel. You're going to get the weirdest name. It basically takes 2 things and mashes them together. So it's interesting to see what it comes up with. The second one I'm not going to kill because it's actually, I run SQL Server on my local machine. Even if I'm on Windows, I run it in a container so I can kill it. So SQL Server inside of a Linux container, I can stop it. It takes no resources when I need it. I start it. It works as Linux as SQL on my local machine, but it only uses resources when I actually need it. Pretty freaking awesome. So we can do docker rm. And then to remove a container, I need to give it either the name, Admiring Mendel, or I need to give it the container ID. Or you need to give it just enough characters of the ID to make it unique. Since there are no other containers whose ID starts with D, I should be able to just kill D. And then look at it, and it's removed the one that starts with D. So it's removed my container. And now it's gone. There's nothing left. There is no recollection of there ever having been anything on my machine running Ubuntu at this moment. Then we can go ahead and we can say a docker run. Let's do IT again so it's interactive. Now I'm going to add --rm, which basically says remove the container once it stops. Don't leave it. I'm just going to play around with it, and once it stops, kill the container. And then I'm going to run Alpine instead. Alpine is another Linux distro, really small. I'm inside of Alpine right now. Let's scroll this up. And I can do ls. You can see I'm inside of a Linux container. And I can do ifconfig. And I can look at the interface configuration. That's about all I can do in Linux. Let's exit that. And if I exit this, I can do docker ps-a, and you can see that my container is now gone and it's never been used. I can also go in and do things like docker run, remove the interactive, and then tell it what command to run inside of that image. And if I run that like this, it starts the container, runs ls inside of that container, outputs the result into my command line here, kills the container, removes it. So if you have repetitive tasks that you do once in a while, you can put them into a container and literally use a container like a command. Just run it for that command, and once it's done, it's off your machine and it doesn't work anymore. So it's quite a nice way of basically abstracting away repetitive tasks into a specific container. But let's see here. I'm just curious if yeah, so I'm going to keep going here. I'm not going to show you more slides right now. Let's do CLS. So starting an Ubuntu container and running hello inside of it is kind of not so much fun. What we want to do is we want to run more stuff inside of it. So I'm going to go ahead and I'm going to run docker run interactive. So I'm going to be inside of my container. I'm going to name the image, or the container, sorry, interactive _ build. And I'm going to map a port on it. Actually, I'm not going to map a port. I don't need a port right now. Let's ignore that. But I'm going to run it off an image. So I'm going to start, instead of using Ubuntu, I'm going to Microsoft/.net 2.2-SDK. So base it off the .NET Core SDK version 2.2 image. I'm inside of it here now. And if I go mkdir app, cd app, so I hop into my app folder, and I do .NET new MVC, it starts up .NET inside of it. It basically creates a new MVC project for me. It restores my NuGet packages. That's kind of cool. I could start this up now and run it and everything, but let's just do exit. Docker, let's just verify that it's still there, ps-a. So my container is here. It has the name interactive build. So now I have a container that has an MVC app inside of it. I want to turn this into an image so I can reuse it. I don't want to do one-off things. Remember, containers are ephemeral. So you should be able to pull up an image or a container, kill it, and start it somewhere else, and it should just work. So you don't do this and then start running that container. You basically do this, and then you convert that container into an image so that you can reuse it. And the way to do that is we do docker commit. I'm going to add some stuff to it. I'm going to tell it that the working directory inside of that image is going to be /app. And I want to add another configuration here. I want to say the entry point. So basically, when this image starts, I want you to run .NET run. And this is what I figured out this morning. --no-launch-profile. That makes the changes work in core, apparently. And then we need to tell it that I want to use the image called interactive build. And I'm going to name my image /interactive. There it is. It takes that long to convert the image into, or the container into an image. So if we do docker ps-a, I'm going to go and say docker rm1. So now that container is gone. Docker images. We can now see that there is a new image in here called interactive tag latest. I created 15 seconds ago. Then we can go and say docker run -rm, remove it when I'm done with it. Map a port. This is kind of cool. So I want you to map port 8080 on my local machine to port 80 inside of that container. And then we want to use the image called /interactive. So that's the image that I want to use. We run that. And for some reason, if your machine is not as slow as mine, it should be up and running by now. I have no idea why it's doing this at the moment. But there it goes. And all the console output is output here because I'm attached to it properly still. Not interactively attached, but the console is still attached. So anything coming out of it would come out of my console. And if we go in here, we open up a Chrome window. We go to localhost port 8080. Ta-da! Okay. So to prove that I'm not faking this, let's go Control-C, docker ps-a. We can now see that it is still up. So the status is up 51 seconds. Let's do docker stop. That's not well spelled. Docker stop 1. Boring Ptolemy was the name of that one. 1 seems easier to spell. It takes a little while because it gracefully lets .NET Core actually stop inside of it, or ASP.NET Core. If we go back out here and I do refresh, you can now see that it goes boof. So it's not like I'm running IIS in the background and just faking it all. I am running this properly, I promise you. But we generally don't like building images interactively. So the reason for that is that to be able to build this image, somebody has to sit down and do everything manually, and it's not something that we can automate. So what we normally do is we automate the generation of images instead. And the easiest way, or the way that you do that, is I have a few projects in here. One of this is just a very simple startup basic MVC application. So it's called demo app. Inside of demo app, I'm going to add a Docker file. So Docker file is a pure text file, and we basically go in and we say from Microsoft, and Rosoft slash, and this is awesome. You get this help here, so we can do .NET, and then we take that and we press enter and we go colon, and then after a little while it tells me what versions are available as well. No, it doesn't. There, well, oh, it did for a little while. Oh, let's just ignore it. Let's just do SDK. So that's the image that I want to use. It does help me. It's just very slow. I have an extension installed to VS Code that helps me with this. Then we say copy, and I want to copy everything in the current directory to /app inside of my container. Sorry, inside of my image /container. Then I want to set up the working directory to be /app. So I want to start the working directory inside of my image is going to be /app. I'm going to run a command in here during the creation of my image called .NET restore. And then I'm going to expose port 80 on TCP. And then I'm going to say entry point. And I'm going to use this really funky syntax that they use for this. So I'm going to do .NET run. And then we do --no -launch -profile. Like that. And that's it. This basically does the same thing that I did in there, except I'm not doing .NET new, I'm doing .NET restore, and I have a proper project already. And then with this in place, I'm just going to add one more thing. You can add a Docker ignore file to basically tell it what happens. It actually takes anything in the folder that your Docker file is located by default. It takes all of that and packages up into what is called a context, which is then used for your builds. If you have extra stuff in there that is not needed inside of your container, you can add a .docker ignore file and say, please do not include the bin and obj folders, because those might be big and bulky and we don't actually need them because we're doing stuff we're doing the run inside the container anyway. So with this Docker file in place, actually I'm going to have to do it in here, I think. So if we open up the console in here, we do cd demo app. That didn't turn out very well at all. What just happened? That's interesting. Let's try this again. cd demo app. There it is. Then we do docker build. We want to build the current directory. So the current directory is where you're going to find the Docker file. And I'm going to add one more thing to it. I'm going to add a tag to it. And I'm going to call it demo app. You can see now that it runs the build and everything for me. You can see the output from every step that I'm doing inside my Docker file. It's now restoring the packages for demo app. There it is. And it does all that inside of my image. And at the end of this, there it is. We should now be able to go back out to this console instead and do CLS. And we can do Docker images. And you can see that my image demo app is in here because I added the tag demo app to it. And it adds the tag latest to it by default. Then we can do Docker run. And we'll run in detached mode. So detached means don't attach the console output and everything like that. Just run it in the background so I don't see what's happening. I'm going to trust that this image works. Map port 8080 to port 80 inside the container. Remove it when I'm done with it and use the image demo app. There it is. It's now starting up. It gives me the hash of the started container. And if I do docker ps-a, you can see that there's a new image is demo app. It's called Cranky Thompson. And the reason I'm talking so much about this before going back to Chrome is because Chrome, it's really slow today, so hopefully it's up and running by now. It's just not impressive when you go out here and press F5 and it goes, nope. And you have to stand here and press F5 over and over and over again. It's my machine, it's not Docker. It's my machine and ASP.NET Core. ASP.NET Core takes a little while to start up in this mode. But there it is. I have an app here, and the cool thing with this app here is what you can see here is actually the OS version of my container is Unix 4.9. And this is the machine name, and I'm in at app things, and I'm in that environment. So that way we can create our images. Let's just do docker or actually that docker stop to just stop my container. We stop that container. Stopping this will also delete it because I added --rm. So using this mode here, we can have these Docker files in our project and basically just write down exactly what we want to do to build our image, and we can have this version controlled and keep track of what's happening inside of our images. Was that cool or was that cool? It was pretty cool. I ran Linux on my Windows machine. That is cool. So, what about storage? Because we all come back to, we need to store stuff. That's just the way it is. And normally, actually, before I do this, I just want to mention to you, you want to make sure that you store as little as possible as you can inside your environment. Shove that out somewhere else. Store it in blob storage or databases or S3 buckets or whatever. Just shove it out somewhere else. Don't store stuff in your container if you can. But if you do want to store things and in your container go and write a file to disk, you have some options. You can store it inside of your container. You can store it using something called a bind mount. You can store it using something called volumes, and you can store it something called temp fs mounts. So storing stuff inside of your container is what I would have done now. If I had gone and written something to disk in my container, I would have written it inside of my container. Container dies, storage dies. Kind of sucks. Bind mounts are cool because I can mount a folder from my local machine or the host that the container is running on inside at the path inside of my container. So when the container reads or writes from a path in your container, it actually reads and writes on your node or on your host. Downside to that is that if you're in a cluster and you move containers around, they're going to move from node to node. So they're going to have localized storage on different nodes, which might suck. But for dev purposes, it's kind of cool to spin up a container, map your source code into your container, and whenever you modify the source code is modified inside your container. Pretty sweet. Volumes is a way for you to have persistent storage that Docker handles. So you create a volume in Docker, and then you can mount that volume into a container. That gives you persistent storage even when stuff moves around, but it's inside of Docker, so you don't really have access to that volume unless you do some interesting stuff to get access to that. So it's basically, I want to have persistent storage inside of Docker. It never needs to leave the Docker environment. Then you can use volumes. And temp fs mounts are basically kind of a cool temporary storage area. It's like adding a path to your container, but the path is only temporary. So you can use that to have things like secrets and connection strings and stuff that should never be shared or never be shown to anyone else. So secret stuff, because it's never written to disk. Everything else gets written to the host, the node or the host that you're on at the moment. It gets written down there if you save stuff, so people can get access to passwords and things like that, even though they're inside of your container. Temp fs mounts things inside of your container in a read area that's basically in memory. So if your container dies, it's gone. The only way to get that out there is figuring out a way to read it off the RAM on the node that you're running, which is going to be slightly complicated. So let's have a look at bind mounts. I'm going to try to do this quickly because I have a few more things to show. So what I've got is a small app in here called Image Viewer. I will show you what the Image Viewer looks like by running. So I have a Docker file in here. It does pretty much the same thing as I did before. It doesn't have the no blah 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 thing that I needed to add because this is an older ASP.NET app that I built before. But let's do cd image viewer like that, docker build, tag the image viewer, and it's in my local folder. So this is going to run my image viewer Docker file, create the image for me. Once that is done, I should be able to go out here and say docker images. Not yet, working on it. Come on, speed up. Kind of sucks that my boss is not in here because I could like ask for a new machine. Docker images, there it is. I have my image viewer up here. So I got a new image in here that has an image viewer. And if we run that, so let's do docker run port 8080 to 80. You are allowed to map other things than 8080. It's just, I don't know why I do that. Everyone else seems to be doing it. I want to run it in detached state. I want to remove it when I'm done with it. I'm going to, actually I don't need to name it. That's just stupid. Actually I do want to name it. Dash dash name. Nope. Image viewer. And I'm going to use the image called image viewer. Like that. Let's run that. That runs in the background. Here is why I spent so much time talking before, because if I go out here and refresh, it's going to say not working, not working, not working, not working. I don't need the no launch thingy because it's an old ASP.NET Core project. If you build ASP.NET Core today with 2.2, you need to have the no thingy that I just added, no launch config. But if you have an old one, which this is, it doesn't have that problem. It's a launch.json issue. So this is an image viewer. It views images that is in my application. So if I go out here, you can see that there's an there's an image folder, sorry, there's a www root, there's and inside that there are images. And I can show those images in my application. Why I've chosen these images, don't ask. It was all I had on my machine. If I go choose file and I choose another image, now I guess the problem is I don't have an image on my machine. Where do you find images? Let's do pictures. Is there something? Oh, I have the best picture in the world. So let's use that. I know that this is the best picture ever on the internet because I searched for the best picture on the internet and I got that. Problem with this is this uploads it and stores it, but it stores it locally. So if I go ahead and I basically kill my things, I go docker stop and I named it image viewer, like that. This is going to stop my container and remove it. Then I'm going to restart my container again with the same image, but it's a new container, right? So I start that. What is going to happen here is quite obvious. So if I refresh this, I've already told you the answer. It's going to be gone. The best picture on the internet is gone. It's gone. Ta-da! Okay, so let's go ahead. Let's go and kill that thing again and do something else. Let's take, what did I do? I want to use that. So what we're going to do now is we're going to map a thing, and this, this should be done. Let's actually do this. I want to do this in PowerShell because I can use a little cool thing when doing it in PowerShell. That didn't work at all. Windows PowerShell does not work. Let's try this anyway. Okay. So I'm going to run the same thing. I'm going to run the same application, but I'm going to go in here and I'm going to add somewhere here. I'm going to say -volume. Please map something for me. And what I'm going to map is, let's do this manually then. I'm going to take, I don't know what is wrong with me in my machine today. Everything takes time. So I'm going to map the folder called, let's go users, Chris, pictures. There it is. I'm going to map this folder. So can you please map that folder to /app/www/images. Start my application with that. So now, even though my image has an www/images folder, I'm actually overwriting that with the folder on my disk instead. So running that, I should be able to go back out here, go F5, and does not work when it yeah. Okay, so there it is, and all of a sudden it works. So if I upload files here now, it would upload it to my local machine into the images folder, and if I killed the container and restarted it, it would still be there because I'm using persistent storage, thus my machine, or my machine in that case. So we can just go ahead and we can do docker stop image viewer. Get out of that. So storage is an interesting kind of thing. You can also bind other things. So you can actually bind not just your local host, but you can actually, if you have a SON or you have, there are drivers for things like S3, and I think in the case of Azure, you can bind things of Azure disks and stuff like that into your container, which gives you persistent storage inside of your cloud instead of inside of using your node or whatever thing like that. So if you do want to mount stuff, you can do that to other things than just local machines as well. Networking is hard. That's the only thing I'm going to say about networking. So a very quick picture of why it's hard is that imagine my machine is connected to the internet or the network, and or to my network at home, and I get 196.168.1.123, and then inside of that I have a Hyper-V switch that runs, so that's 10.0.75.1. Inside or connected to that Hyper-V switch is my Docker VM Moby Linux, which is on 10.0.75.2. Inside of that I have my Docker network, which is 172.17.0.1. Inside the Docker network I have my containers at 172.17.0.2 and 0.4. And whenever your container goes up and down, ta-da! So you cannot expect IP addresses or anything like that to just magically work. There's no way, there's no good way of making these static. So you should never expect a container to be at a specific IP address. You need other ways of locating that image. And what I'm saying about the setting up Docker for desktop is the fact that when I run Docker here, it looks as though I am communicating and setting things up in here. When I do port mapping, so basically when I port map port 8080 on my local host to port 80 inside of a container, I am port mapping from this through this into that. And networking is hard. I have no idea how to do it, but it works. So leaving that, let's go into Docker Compose. We rarely want to deploy one container. We want to deploy multiple containers. Docker Compose does that for us by having a compose YAML file, and inside the YAML file we basically say, I want to run a couple of different services. I want to run Nginx, reverse proxy, that's built for Linux, and I want to map some ports to the Nginx stuff, and then I want to run my web application as well, so I want to run a container called web, and that web thingy in my demo is also going to be dependent on a Redis cache. So I need to spin up 3 containers for it to work, so that when I talk to it, I talk to the Nginx container on port 8080, which then talks to the web service or the web container inside of the Docker network, that then talks to a Redis container inside of that Docker network. And Docker Compose does that automatically. So Docker Compose actually goes and sets different networks and connects them together into a virtual network. And we can add things like environment variables and a bunch of different things to our Docker Compose. And all we do is Docker Compose up, tell it what Docker Compose file to use, and it spins up all the containers for us, connects all the network and everything, and magically I have in this case, a 2-container thing running for me. So doing that, I'm just going to do this quickly. I have a reverse proxy compose application here. And that application depends on 3 different things. It has a web app, it has an Nginx reverse proxy, and it's going to have a Redis cache. So what I'm going to do is I'm going to go in here to this, and I'm going to add a new file called docker-compose.yaml, like that. I'm not allowed to add that because there's already Docker Compose YAML in here. That's good because I didn't have to write it. Okay, this is what I was supposed to write for you. And as you can see, all we do is we say, okay, what version of Docker Compose are we using? Or the format. What services do we want to run? I want to run a web service, and I'm telling Docker Compose that I want you to build that thing for me. It's not an image you can just download off the web. You need to build it for me. You can find the context for that application, so it's located at /app. And I want to set an environment variable called Redis, so inside of my app, I look at the environment variable called Redis to find the host name of my Redis cache so that I can read stuff from my Redis cache. Then I want to have another service called Nginx. I want you to build it based on this context here, and Nginx is really cool because all I do in here is I take the Nginx Alpine thingy and I copy a single conf file into it and I'm done. So that's all Nginx needs to set up reverse proxy. And then I want to run a Redis cache as well, and luckily both Nginx and Redis are basically, there are pre-built images for us for that on Docker Hub, and they're controlled, which is why they're only named like Redis and Nginx. They don't have a prefix like Microsoft / something. They are official things from Docker. I'm not telling it to use specific networks. If you don't tell them to use specific networks, Compose will create a default network for you and connect all of these 3 services or containers into a unique network for that Compose. So if we take this thing and we do, nope, that's not what I wanted. Let's do it in here. So let's do cd reverse proxy compose, and we'll do docker-compose. So Docker Compose is included when you install Docker for Desktop. Up. So it tells me exactly what it's doing. It now set up a network called reverse proxy compose _default. It builds my web application for me. I've got 4 more minutes. It's building my web app for me. That's it. It's building my Nginx image for me, because I had the Nginx image on my machine already. If I hadn't, it would have pulled it for me automatically from the web. It's set up Redis, so you can see the output here from Redis saying that I'm up and running. Redis is running. The web is now up and running. The Nginx stuff is up and running. So if I go out here, and I go localhost port 8080, and I load this, it works. And nobody's impressed But I just want to show you a couple of things here before I end. So if I reload this thing, you can see that it doesn't change the initial request date, which means that I know that it's actually caching the request date in a Redis cache. All I needed to do to run this environment on my machine is docker compose up. It runs 3 containers in its own discrete network. I cannot access the web without going through Nginx. So I have the proper pipeline that I would then deploy to a host somewhere, and I can run it locally on my machine. And when I'm done with it, I can just go back here and say exit, and it stops everything for me. And if I do docker compose down, it's even nice enough to remove all of the running containers and the network for me. So we can define, if you've got a system depending on several different services, you can have a compose file that spins everything up for you, sets up the network and everything for you, and it just runs on your machine. That is pretty epic. I have 2 more minutes. That's kind of cute, but it's only on my machine. If you want to go, because Docker makes no sense to run, well, it does, but it's not like I'm going to run everything in Docker because it's cool. You can do cool stuff with Docker on just one machine. Example, if you want to, have you been to the Microsoft stand out here? They will give you a Raspberry Pi. If you go home, you get that Raspberry Pi, you install Docker on the Raspberry Pi, you install an image called Pi-hole, and that becomes a DNS server for you with a web interface. You install that as the default DNS on your local network at home. It will filter out spam and ads. So basically, it will DNS block different domains that I know that are spam and that are ads. So basically, you get ad blocking on your network running inside of Docker, which is kind of cool. But if you want to go more than that in the cluster, you can use Docker Swarm. Don't. You can use Mesos or DCOS. That's kind of cool. Never done it. Could be kind of cool. But everyone seems to be gravitating toward Kubernetes. So Kubernetes will set up a cluster of machines. You tell Kubernetes a desired state. I want to run 3 instances of this container. Just fix it for me. I don't care. If nodes go down or come up or whatever, please load balance them. Make sure they don't use more resources than X and so on. So basically, it controls and self-heals your deployment. You can run Docker for Windows. The images become clunky and big and heavy. That's just the way it works in Docker for Windows at the moment. But you can do containers on Windows. It's just a little bit different than this. And that's kind of it. On time. Thank you all for listening. If you have any questions, I will be around. You can ping me on Twitter, fill out the evals if you liked the session. If you didn't like the session, as usual, come up, talk to me. I'll explain why it was awesome, and then you can fill out the eval.